Alex before. So go ahead, Alex.
Cool. Hello everyone. Like Dr. Banerjee said, my name is Alex Benson. I'm a master's student in the Banerjee group at Texas A&M, and I'll be presenting today with Ben Rogers on some comparative evaluations and life cycle assessments of vanadium industry and vanadium technologies, looking at alternatives to structural steel and energy storage applications. Specifically, today we want to, if I can, there we go. Kind of go into our outline. We want to talk about some environmental benefits of vanadium. Specifically, we'll start with an industry overview, looking at some of the work we've done with our databases, specifically the MINES database, and then as well the VRFB database that we maintain. And then we'll look at some previous work that we've done, just kind of a quick overview of our life cycle assessments of the vanadium steel and VRFBs, and some projected carbon emission benefits of vanadium. And then we'll just kind of briefly touch on some previous publications that we've submitted, and then discuss our proposed work, which will be building some new market projections, continuing to work on our databases and developing those, and then making a kind of environmental case for vanadium over niobium through carbon emissions and embodied water savings. So diving right into just a brief industry overview, we've kind of touched base on this before, but we consider some key vanadium technologies being rebar, steel in various industries, and VRFBs, and some critical regions that we look at currently being Australia, China, and the EU. And so kind of what we've done with that is actually started a new database, as you can see here. This database has kind of been the culmination of the last year or so of work on my part, and as well kind of Ben's work starting out, where we have worked to kind of track all of the mines and processing facilities that produce vanadium kind of on a global scale. As you know, we kind of saw kind of going back to COVID, not being able to understand the supply chain kind of created a lot of issues for people. So we wanted to really kind of qualify and quantify what that looked like. And so what that has kind of turned into is, you can see here, this is kind of a visualization of that exact effect, kind of a global projection of all of the mines and processing facilities that we kind of currently have knowledge of across the world, as well as kind of production, kind of doing a quick production analysis of vanadium by source and by country, and kind of looking at where vanadium is coming from, where it's being processed. And so what that kind of looks like in our internal database is we kind of have two different data sets that we store. We have a set of qualitative data as well as a set of quantitative data. And so what we've kind of identified as important data points that we want to keep track of are the resource type, as well as kind of where we're getting our information and when we are kind of updating that information, as it allows us to do kind of historical data tracking, where vanadium's coming from, where new mines are being developed. But we really want to know, as we are kind of bringing this database to maturity and getting ready to go live with this database, specifically in terms of the mines, as you can see some examples here, we're still trying to flesh out fully what kind of information we are trying to track and provide for everybody. And currently we have information like the ore grade and inferred and indicated resources, as well as the annual production output of the mines. But we want to know kind of what other information we should be tracking, and we'll go into a lot more detail in the meeting on the MDC meeting on the 27th. And so this is kind of a great time for anyone here to kind of send us emails letting us know what information they think would be valuable. But currently we're looking at tracking primary versus secondary versus co-production, and where the vanadium is coming from there. And also, we want to know, like, uh, is it worthwhile to track inferred and indicated resources, or just kind of providing an overall total number, um, And then as well, like the production, like the annual production, that value is a little harder to find for most mines, but we think it's a very valuable piece of information to include. And if there are any other data collection methods that we can employ. Currently, we try to use the JORC reports because those seem pretty standardized, and it seems like most people are providing those for those mines, which is fantastic. But we want to know, are there other reports that we can kind of look at? And so, uh, just to kind of help us flesh out this database. Within this database, we are also looking at processing facilities. We received a lot of questions and helpful comments as to, kind of growing this database, especially so on the processing facilities. And one thing that we want to highlight is the different ways that we are tracking the capabilities of the processing facilities. I think most people understand there's a limited number of ore types that vanadium can come from, but processing those ore types is kind of an equally important conversation. And so the way we kind of break down the information in our database specifically is looking at the facility type, and we kind of quantify those or qualify those as primary and secondary facilities. Primary being the facility's main kind of dedication is towards processing vanadium, whereas a secondary facility is totally capable of processing vanadium and it has the capabilities to scale, but that's not their kind of only focus or their primary focus necessarily. And so that line is kind of blurry, but we're making that distinction. Um, and then as well, we're looking at the resource type. So the way we're kind of tracking it at the moment is looking at processed vanadium, so vanadium solids, vanadium oxide, vanadium oxalate, different kind of solid vanadium materials, and then also electrolyte. And one thing we've seen is there's different kind of chemical formulations for electrolyte. We have not kind of gone so far as to tracking that at the moment, but that is also, if people are interested, if that's kind of a point of interest, something that we can certainly track as well. Um, and then again, we want to know, we want to hear from people to know kind of what else we should be tracking, what other information or, what information people would find most useful. And so, we're kind of debating the product type. So, going into specifics of like metavanidates, vanadium oxide flake, which is something that we've done a little bit, but not to the fullest extent that we certainly could. And then again, the electrolyte type and the annual production capacity, that is something that is probably going to be very challenging for us to track. But if that is something that is interesting, we can certainly include what data we can ascertain. And then also the source. So, it would be beneficial in a lot of cases, from our viewpoint, to be able to say like what kind of what source the processing facility can take in and then process the vanadium out of. So that again is another area that we think we could expand the database into. And we intend to go live with this database. This will be kind of our first live iteration of our supply chains database on October 31st, which will be after the kind of annual MDC meetings in Leshan. But we're hoping to kind of get this published on the Vanatech website, very similarly to our VRFB database. And so that's another thing that we wanted to just kind of introduce to everybody. We have been developing this database of VRFBs. This one has actually predated me by a few years, by kind of my colleagues and mentors on this project, and we are actively updating it and keeping track of it. And so you can see, as this one is a lot more mature, we have a much, much wider kind of analysis of where the VRFBs are. And we're very interested in kind of displaying and analyzing the kind of global distribution of VRFBs. And you can see that we have been able to visualize that here. And so kind of what this database looks like internally, you can see, again, there's a few examples of this here. We track, again, both qualitative and quantitative data. And kind of we've received a few questions that have been very helpful in kind of helping us continue to develop this database. Specifically, we've recently added the information source as well as the kind of date at which we update new entries. This all allows for historical data tracking again, which is kind of why we incorporated that into the Mines database as well. And one thing that we're kind of interested in kind of expanding this database into as well is tracking the use case for VRFB installations, whether that be a hospital or load leveling microgrid, wind power, or baseline supply for a steel plant. These different use case applications will have different grid mixes. There are differences for long duration energy storage project planning and kind of a different effect when it comes to kind of the models that we want to develop for carbon emissions and such. And so we want to know again, is there other information that we should be tracking? And this is something that we hope to kind of go into a more detailed discussion of in the MDC meetings on the 27th of September. Um, and so I'm gonna go ahead and pass it over to Ben quick so he can talk about kind of the previous work that we've done and kind of new work that we'll be extending to. So yeah, Ben, if you want to take it away.
Thank you, Alex. So as Alex said, my name is Ben Rogers. I recently started here at Texas A&M, and one of the things I wanted to talk to you guys about today is one of the ways that we've studied vanadium materials here at Texas A&M University, which is through what we've developed called the Life Cycle Assessment Framework, with 4 key parts: modeling, material savings, the inventory analysis, and the impact assessment. Now, with this life cycle assessment framework, we're looking towards the next way to utilize it, which is through what we want to develop, a vanadium carbon footprint calculator. We're still developing this calculator now, so we're open to input on different parameters for inputs as well as outputs for different values that an audience can interactively engage with to quantify and interactively determine the carbon emissions savings from using vanadium materials. We've got a number of different considerations that we've already taken into mind as we've begun developing this calculator, including the global distribution of vanadium materials, as well as the stratification of those materials by industry. And additionally, we look at the different use cases. So whether the vanadium is used in materials like steel, rebar, and beams in construction, or whether the steel is going to be used in vanadium redox flow batteries, such as and then within those use cases, you get individual cases as well, such as purpose of the vanadium redox flow battery for load leveling a microgrid, supplying baseline energy, or whether it's used for backup power in a building. Additionally, we'll have a number of computational assumptions, and we're still determining the scope of the calculator. So if we want to move to the next slide, we'll see some of the previous work that we've already done has tested a lot of these different assumptions that we've made and making these calculations for carbon savings. Some of these are just setting up simple boundaries for what we want to assume a vanadium redox flow battery can operate as. So for example, we have to assume the cycling frequency, 1.12 cycles per days, across a lifetime average of 20 years. These kinds of boundaries are going to help us make the calculator more efficient and giving discrete quantified carbon emission savings for the use of vanadium materials. Our previous calculations for vanadium redox flow batteries have already given us a large basis for looking at the different ways that we can study vanadium redox flow batteries within the broader scope of vanadium materials overall. So for example, we can take information provided by Guidehouse Insights, which gives us an energy to power ratio of 8.3, which then we can use in the calculations to look at the overall duration of the batteries as well. We also have assumptions such as the charge-discharge efficiencies and nominal energy densities, which both give us quantifiable information that we can use within the life cycle assessment framework and apply those in the vanadium carbon footprint calculator. Now, if we move on, we'll see some more previous work where we've done embodied energy and carbon emissions studies of vanadium technologies in buildings. We've applied the life cycle assessment framework using structural modeling of materials such as conventional and high strength low alloy steel to quantify the total impact of the vanadium material. We've seen significant savings in embodied energy costs through carbon dioxide comparative reductions. We've seen up to a 61.06% savings in steels as just one of the ways that we've quantified the impact of vanadium material use. Now, these previous studies we've looked at engage all aspects of the life cycle assessment framework, but what we want to do is take these calculations a step further and allow the public to interactively engage with these through the vanadium carbon footprint calculator. These previous calculations are what we want to build eventually as we continue to develop the carbon footprint calculator. Now, if we move on, we'll see the embodied energy and carbon emissions of vanadium technologies has also been studied here at Texas A&M University through vanadium redox flow batteries. When coupled with a wind source, we found that there is a savings of 2.13 million metric tons of carbon dioxide across the 20-year lifetime of a vanadium redox flow batteries. Now, this carbon dioxide emissions reductions, we've seen significant comparative reductions, such as the figure on the right in a recent publication here at Texas A&M University, where we found that vanadium redox flow batteries have much smaller carbon footprint than your typical lithium-ion battery system. Again, on the bottom right, we see a different comparison using the production, replacements, and use comparisons of the vanadium technologies with respect to the overall carbon dioxide emissions. These impacts are fairly large, but what we want is to take them a step further in the vanadium carbon footprint calculator to allow projecting those quantities as users engage with it. So with all this previous work, we've had a number of high-profile papers here at Texas A&M University just in the past few years. And these papers have resulted in 2 cover papers as well in the journals. But with this previous work we've done at Texas A&M University, I'm now going to hand it back to Alex, who's going to talk a little bit about what we have right now in the works.
Yeah, thanks, Ben. So kind of diving back into what we are working on at the moment, we are currently developing an additional publication that kind of analyzes what we've done with the development of the new databases, specifically looking at the diversity of the vanadium supply chain, the carbon savings from VRFB grid integration, which kind of been touched on a moment ago, and then strategies for resilient supply chains and cost structures, 3 of which we have kind of identified as good strategies for the development of the vanadium industry moving forward, specifically looking at the electrolyte leasing program, offtake agreements that we have seen on the rise with a number of the mining companies in Australia, and then also our argument for a strategic metals database, a model for policy to drive demand for mined vanadium. And what we are proposing to do kind of as future work after this is develop new and rigorous market projections for high strength, low alloy steel and VRFBs as well. There are a number of projections showing that the global construction market is going to kind of explode in the next decade, with China, India, the United States, and Indonesia driving the kind of the majority of that growth. And within those countries, there's a number of environmentally friendly policies that drive the need for better battery solutions and increased energy storage capacity. And as such, the VRFB market is projected to reach over 1.2 billion by 2030, which is a compound annual growth rate of roughly 20% year over year. And so we are also hoping to kind of develop a comparative LCA to reinforce vanadium's environmental benefits by doing a comparative evaluation of vanadium and niobium production processes to kind of substantiate the lower environmental impacts of vanadium. We also want to kind of validate the environmental benefits of vanadium in different technologies, looking at specifically vanadium steel and VRFBs as kind of our primary technologies, And we will do all of this through carbon emissions, embodied energy, and embodied water savings for primary niobium versus primary vanadium production, co-production, and recycling. And so, our proposed effort will kind of culminate in a number of deliverables, specifically research papers, peer-reviewed research papers focusing on the energy, carbon, and water nexus approach. We are also looking to project future construction and VRFB market growth. And obviously, we'll continue to present an update to discuss progress and any final results, and continue to provide quarterly updates on the vanadium data repositories that we have been developing over the past year. And with that, I want to thank everyone for their attention. And yeah, we're looking forward to continue providing a number of very interesting studies that we are working on. And if anyone has any questions, we would love to take those now.
Thank you very much, Alexandra and Ben, for interesting presentations. Any questions or comments on that for the team from Texas A&M?
Hey, Alex, this is John. Can you go back to slide 7 for a moment?
Slide 7, yeah. There we go.
It's a little slower on our end. There it is. So under facility type, are we going to track electrolyte processing facilities too, or just primary and secondary processing?
Both.
So,
Yeah.
Go ahead, Dr. Banerjee.
No, I was gonna say, John, we want to do both, right? So primary, secondary, and then electrolyte, and then ultimately maybe even electrolyte type.
Okay. So that'll be in a
Um,
facility type will be a third category.
Yeah, we don't have that fully. Oh, I guess you did make that on the spreadsheet now, Alex, right? You do have.
Yeah.
But when we send it out again, this database, our latest beta version after the MDC meeting, John, I'm hoping people can comment and just sort of do a bit of fact checking on anything they know about.
All right, thanks.
Yeah, so currently the way we track it is it's kind of split between two separate columns. Facility type tracks whether or not the facility is primarily dedicated towards producing vanadium. So something like the Australian vanadium processing plant, their primary kind of output is going to be targeting like a vanadium oxide. That's going to be kind of their primary product. Whereas like Oxchem, their facility can process vanadium and they have a very large processing capability for vanadium, but they also produce a number of other materials. And so that's the vanadium's not their only kind of dedicated product. Therefore, we kind of dedicated them or designated them as a secondary facility. And then under resource type, we actually track whether or not like kind of what they can produce. And so the Australian vanadium processing plant can right now it's going to be dedicated towards producing vanadium oxide, whereas something like the Oxchem facility can produce vanadium oxalate as well as a number of different electrolyte types. So that's kind of how we have designated that. So we do have the capability at the moment to track whether or not the facility can produce electrolyte or if it's producing kind of a solid processed vanadium. But that is kind of a separate column from whether or not it's a like what the facility I guess the facility type and then the product type are two separate columns at the moment.
So resource type is not the resource that they're having as an input to the process. The resource is their output. That's
Correct. Yes.
That seems a little not confusing, but resource seems to me like this is where they're getting their material from versus
That too. We could clarify that, maybe make it product type, and then we could have a specific resource type column as well that is primary or a secondary coke or something like that.
I think it'd be helpful.
And that's what we were hoping to move toward. When we first started this, we only had the resource type, which for at the time the mines and processing facilities database was combined, and so the resource type was for the mines it was the resource that they were like the kind of the ore that they were kind of mining, and then the facilities it was convenient to add it to the same column, but we kind of split the two databases. And so yeah, that's something that we can very easily separate to make it much more clear.
Thank you.
Mm-hmm.
Okay, well, thanks very much. In the interest of time, I'm afraid we're a little behind time, so I think we better call a close to questions on debate and on this presentation. So thanks again to the team from Texas A&M. The final part of the agenda is looking at two new project proposals, and the first one takes us back to Kevin Banks at the University of Pretoria. So